So here we have Energy FRQ Practice from the Physics Honors Curriculum, Unit 4. So here I listed some important formulas: gravitational potential, kinetic energy, elastic potential, velocity, and spring compression. I want to emphasize that these two formulas will not be on the formula sheet. You will need to know how to derive them from the kinetic energy formula, solving for V, and the elastic potential formula, solving for X. Both have similar structure in the sense that you are solving for each variable. There's a similar progression. Just make sure you know how to do the algebra and isolate each variable. It is an essential skill for the exam. So here's our scenario. A 0.5 kilogram block is located at the top of a ramp, 1.2 meters above the ground. It slides down the ramp, around a loop with a radius of 40 centimeters, and finally compresses with the spring. The spring constant is 90 newtons per meter, and in today's scenario, there will be 4 parts, and we need to use the information provided to answer each question. So first, let's annotate the diagram, understand what's actually going on in the scenario, list our knowns and unknowns. So over here, we made sure that we converted centimeters to meters because that is the standard unit. In physics, we need to make sure that we're using the correct units like kilograms, meters, seconds, and more. So for part A, we need to use the diagram provided to find the potential energy at point A, which is right over here. So since there is no kinetic energy or elastic potential in this situation, we know we need to use the GPE formula, gravitational potential energy. So here we have it. We use the correct formula, we plug in our numbers, and we understand that joules is the standard unit for energy in this example. So the total energy at the highest point of this diagram is 5.88 joules, and according to the law of conservation of energy, it proves that there will not be a total energy value throughout this whole scenario that is greater or less than 5.88 joules. So basically, in this whole scenario, no matter where the block is on the progression, all energy will always add up to 5.88 joules due to the law of conservation of energy. Energy cannot be created nor destroyed. So we need to keep that in mind for future questions, and maybe it will be the next one. Using the diagram provided, calculate the velocity of the block at point B. So we understand that point B is over here at the top of the loop. We converted our units, so we know that we're going to be plugging in the correct values. And let's dive into the explanation. So to find velocity, we first need to figure out that the GPE and KE of the block at the top of the circle. Using GPE, we use the law of conservation of energy to find KE. Again, this popped up. Make sure you understand this law because it is essential for the exam. Finally, we use the velocity formula, which was derived from the KE formula. You will not have this formula on your formula sheet. You need to know how to derive it using algebra. You need to plug in and solve. So first, we want to find the GPE of point B. So we use the GPE formula. Remember to use the correct diameter, which is in meters, not centimeters, and we get 3.92 joules. By the law of conservation of energy, we can subtract the total amount minus the GPE to figure out the KE at this point on the progression. And now we calculate velocity using the formula we derived, which is right here, plug in numbers, and we use meters per second as the unit for 2.8 as the velocity. Remember to plug this into your calculator correctly. I cannot stress this enough. Using the calculator correctly is essential. Make sure that you're plugging it in such that the calculator understands what you're trying to get done, and it's not following a different pattern of orders of operations based on how you plugged in the numbers. So for part C, we want to find the total energy at point C. So right here, obviously this is a flat portion of the track. The block is moving with solo kinetic energy. There's no other energy acting upon it, no elastic potential, no gravitational potential, because it is on the ground and moving towards the spring. So we want to use the KE formula, or we can solve it an easier way, which will be described on the next slide. So here's the explanation. Since the only energy at this point is Ke, as stated, we can use the law of conservation of energy to answer this. This is the easy way, more efficient way, as it saves you time on the assessment. We only have 40 minutes to complete this exam, so please use it to the best of your ability. So yeah, the law of conservation of energy means that the energy transfer is all 100%. The total amount of energy for the block at different portions on the diagram all add up to 5.88 joules. So we can conclude that the value of Ke at point C is 5.88 because it's all kinetic energy, so that means it's all 5.88 joules. And we actually cannot use the Ke formula because the Ke formula, mass times velocity squared, velocity at point C is unknown. We do not know the velocity at point C. Obviously, we can compute it, but this takes more work, more steps, and we do not have the time for this. Again, an extra step is required. Efficiency is of the essence in the upcoming exam because only 40 minutes is allotted to complete this unit test. So part D asks us to find the compression of the spring at point D on the graph. So we want to find how much the spring compressed, how many meters the spring compressed after collision with the block. So essentially, we want to solve for X, which is the parallel displacement or the spring compression. Again, we do not have this formula. We need to derive it from the EPE, elastic potential formula, using algebra, essential skill for the exam. So even though it may seem we don't know EPE, all of the kinetic energy from point C, again, I can go back to it, from point C, right here, has been transferred into the spring, which means all 5.88 joules has been transferred into the spring. So that means we actually do know elastic potential in this situation. We know that elastic potential is all 5.88 joules. We derive our formula, square root both sides to solve for X, and we plug in 2 times 5.88 over 90, which is the spring constant. Do not forget about that spring constant. It is essential in completing this question. So we compute, plug it into the calculator, and we get our answer to be 0.36 meters. Again, this could show up on your exam, or you can get the velocity question. Both are quite similar. I included both in this scenario, so we could go over the material, understand what's actually going on, and we will be prepared for the exam. So in conclusion, we learned how to correctly show our work for each part of an energy FRQ from Physics Honors Unit 4. Use the information you learned today and apply it to the upcoming exam. I want to stress that you need to remember your units. Remember your formulas. Obviously, we will have a formula sheet, so know how to derive formulas, solve for different variables, and remember your scientific laws, specifically the law of conservation of energy. And finally, this is not stated, but know how to use your calculator. Plugging something in wrong, but having all the right values is, it's just terrible. If you plug in the right numbers, get the wrong answer just because you plugged it in wrong mathematically, using wrong order of operations. So please know how to use your calculator, know your scientific laws, remember your units, and know how to use the algebra, and you will be set for tomorrow's FRQ. Thank you.